Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P16E2 indicates a PGM-FI-ACG LIN communication error in the Honda Pilot models from 2016 to 2022. The acronym PGM-FI stands for Programmed Fuel Injection, which is critical for ensuring the engine operates efficiently by controlling the fuel injection process. The ACG refers to the alternating current generator, commonly known as the alternator, which provides electrical power to the vehicle systems and recharges the battery. A LIN, Local Interconnect Network communication error, signifies a disruption in the communication line shared between these components, essential for transmitting operational data. The alternator is typically located at the front of the engine, attached to the engine block. This error suggests potential loose connections or faultiness in the electrical circuit, affecting the electrical supply and communication between the engine control module, ECM, and the alternator. Understanding this error's implications is vital to maintain the vehicle's performance and electrical integrity. The error described by DTC P16E2 involves the PGM-FI-ACG LIN communication, which directly affects the interaction between the engine control module ECM and the alternator. The alternator is responsible for generating electrical power to recharge the battery and power the electrical systems when the engine is running. The powertrain control module, PCM, or ECM, is the vehicle's brain that manages the engine's performance and operation. When there's a disruption in LIN communication, the vehicle may encounter issues related to its electrical functionality, which could manifest in multiple vehicle systems. It is essential to first locate the alternator in the engine compartment and check the connections thoroughly, particularly the +B terminal that directly impacts the communication error. This communication line coordinates various inputs and outputs. Thus, any malfunction can lead to system inefficiencies, ultimately setting this DTC. Several possible causes can lead to a PGM-FI-ACG LIN communication error, specifically DTC P16E2. The most common is a loose terminal connection at the alternator's +B terminal. This loose connection can interrupt the flow of electrical signals between the alternator and the ECM, thus triggering the error code. Another cause could be faulty wiring, particularly within the LIN communication circuit, which can be affected by wear, damage, or corrosion over time. A failure in PCM communication can also lead to this DTC. The ECM needs to receive accurate information from the alternator to function optimally. It is essential to conduct a thorough inspection of these components and connections, as they are vital for maintaining efficient vehicle operation. Any failure in the above areas can immediately result in the activation of DTC P16E2, indicating that detailed troubleshooting is required. DTC P16E2 is likely to manifest through several symptoms that indicate underlying electrical issues. Drivers may notice warning lights activating on the dashboard, signaling that something is awry with the vehicle's electrical systems. Commonly, these will include check engine lights or battery warning indicators. Additionally, electrical system malfunctions may occur, leading to problems like dimming lights or failure of electronic accessories. Engine performance may also deteriorate as the ECM struggles to regulate the engine functions without accurate data from the alternator. In some cases, drivers may experience stalling or difficulty starting the engine. Recognizing these symptoms promptly can aid in timely diagnostics and repairs, preventing further complications down the line. The first step in troubleshooting the P16E2 code involves verifying the problem through a series of simple actions. Start by turning the vehicle's ignition to the on mode without starting the engine. This enables the vehicle's electrical systems for diagnostic reading. Next, use the Honda Diagnostic System, HDS, to clear the DTC and wait for approximately 10 seconds. This ensures that the system refreshes and allows for accurate testing. After clearing the DTC, you should check for any pending or confirmed DTCs using the HDS again. This process is crucial as it helps identify whether the P16E2 code is currently active or if the problem was intermittent and resolved. Understanding the current state of the DTC is essential before moving to subsequent steps. In the second step, you will once again check for pending or confirmed DTCs using the HDS. Confirming the state of the DTCs is fundamental to understanding the issue's coherence with the electrical systems of the vehicle. After this, you will specifically look for the presence of DTC P16E5, which indicates a related PGM-FI DC-DC converter LIN communication error. If P16E5 is indicated alongside P16E2, it suggests additional complications in the communication lines or components overall. Depending on whether P16E5 appears, you'll either proceed to Step 3 if it is present, or jump directly to Step 7 if it is absent. Ensuring that all related codes are reviewed aids in providing clarity and direction in the troubleshooting process. In troubleshooting Step 3, the goal is to determine the failure area within the communication circuit, focusing on the LIN communication line. Start by turning the vehicle's ignition to the off mode to ensure safety before working with electrical components. Next, you will disconnect the alternator 1P connector. This connector plays a critical role in linking the alternator to the rest of the electrical system, thus isolating it for testing. After disconnection, check for continuity between test points using a multimeter, wherein one test point is the alternator's 1P terminal and the other is the body ground. Performing this continuity test while the vehicle is off will help you understand if there are any shorts or malfunctions present in the LIN communication system. If continuity exists, the troubleshooting will continue. If not, further steps will be required. In Step 4 of the troubleshooting process, the focus turns to isolating any issues in the LIN communication line. You will first jump the SCS line using the HDS and wait for more than 1 minute. SCS stands for the Security Check System, designed to ensure the integrity of the diagnostic software. Once this is completed, you will check continuity again between the alternator 1P connector terminal and body ground, following it up by disconnecting other connectors step by step. The PCM connector B, battery fan motor connector, and DC-DC converter connector. Observing whether continuity disappears once one of these connectors is disconnected will inform you about any additional faults on the LIN communication line. If continuity disappears with any connector disconnection, then the LIN wire is functioning properly. Subsequently, it would be necessary to replace the part that caused an open. If not, it indicates there's likely a short in the LIN wire that needs repairing. Step 5 involves narrowing down potential faults related to the alternator and other components in the circuit. Start by reconnecting the alternator 1P connector to set the baseline for testing. Next, disconnect the DC-DC converter connector A. This component, part of the electrical system, plays a role in managing power flowing through electrical circuits. With the DC-DC converter connector disconnected, check for continuity between the test points of the DC-DC converter connector A and the body ground. If continuity is confirmed, this indicates that the alternator is likely failing and should be replaced as the root cause of the problem. If not, the troubleshooting will advance to Step 6, which will examine open wires in the LIN communication line. for additional issues. In troubleshooting step 6, the check focuses on identifying open wires within the LIN communication line. Start this step by jumping the SCS line again using the HDS, similar to previous steps, and waiting for more than 1 minute. This will help ensure that the SCS software is functioning properly. After this, disconnect the relevant connectors from the alternator, specifically the alternator 1P connector and the PCM connector B. You will then test for continuity between the alternator 1P connector terminal and the PCM connector B terminal. If continuity is confirmed, this suggests that the LIN communication wire is intact. In this case, checking for authorized service information related to these DTCs or substituting a known good PCM would be the next prudent steps. If continuity fails, however, this indicates there is likely an open in the LIN wiring that requires repair. The final step in troubleshooting DTC P16E2 engages another continuity check to confirm the integrity of the LIN communication line. Begin by ensuring the vehicle is turned off and jump the SCS line once again with the HDS for a minute. Following this, disconnect the alternator 1P connector and the PCM connector B to isolate the wiring for testing. Check continuity between the alternator's 1P connector terminal and the PCM connector B terminal. Confirming continuity in this configuration means that the LIN communication wire is functioning correctly. If continuity is absent, there is likely an open in the wiring between the alternator and PCM that must be repaired. This final check is crucial as it directly addresses the error code concerns, bringing you closer to resolving the issue. After addressing the wiring or component issues depicted by DTC P16E2 through the prescribed troubleshooting steps, it is vital to perform a final repair verification. Start by thoroughly rechecking the entire vehicle systems that were involved during the troubleshooting process. This could involve reconnecting any components previously disconnected and ensuring all terminals are properly secured. After reconnecting, utilize the Auto Diagnostics System, HDS, to verify no DTCs are present in the system. Confirming the absence of DTCs is essential as it indicates that all previous issues have been resolved effectively. Lastly, conduct a test drive or simulation, if applicable, to confirm the vehicle operates smoothly, ensuring that the electrical systems function without interruption or malfunction. Ultimately, this step is crucial for ensuring that the repair made is both effective and reliable. Implementing routine preventive maintenance can significantly reduce the occurrence of DTC P16E2 and similar errors in the future. One critical practice is to regularly inspect all electrical connectors, particularly those linked to the alternator and PCM, ensuring they are secured and free from corrosion or damage. Furthermore, maintaining the integrity of the wiring is crucial. Any signs of fraying or wear should prompt immediate attention to prevent eventual electrical failures. Regularly checking the alternator's functionality helps determine its health and can preemptively address issues before they escalate into problems that affect vehicle performance and reliability. Finally, always adhering to the manufacturer's guidelines regarding servicing and maintenance can enhance the vehicle's longevity and operational efficiency, allowing you to enjoy a problem-free driving experience. In conclusion, understanding the implications of DTC P16E2 is essential for maintaining your Honda Pilot's performance. This error highlights crucial communication issues between the alternator and the ECM, emphasizing the importance of proper connections and wiring integrity. It is vital to follow the structured troubleshooting steps outlined to accurately diagnose and repair any faults. Each step in the process is designed to lead to a thorough understanding of the underlying issues, thereby ensuring effective repair. Furthermore, being proactive with routine maintenance and inspections will further mitigate risks associated with electrical failures and enable the vehicle to perform at its best. By staying informed and attentive to these aspects, you'll not only enhance your driving experience, but also extend the life of your vehicle. Please like and subscribe to the channel. See you next time.